Excuse me. Comparing proportions. Um, so I think one of the unfortunate things about statistics is that it uses p for just about every variable, it seems like, right? Probability, p-value, those are actually the same thing. I don't know why they call it two different things. P hat, sample proportion, p, the population proportion. So it's all about context as to what p we're talking about. So today we're going to be talking about proportions. And I think the thing that we've struggled with many people have struggled with, or at least a number of you, is how do I tell the difference between a proportion and a count? So, you know, I think the hard thing about being a teacher is I don't think the difference between proportions and counts is all that hard to identify. And I think maybe it's because of, what I learned probably when I learned it. I don't know. So the problem with being a teacher sometimes is if it's something that you think is fairly obvious, like I don't know that I'm a very good geometry teacher because to me geometry is like really super simple. And yet there are people that really struggle with geometry, where I would struggle more with the algebra. So I'm a better algebra teacher because it's something I struggle with, and I understand that struggle than something I don't. So anyway, proportions, it's when you have something like, hey, 25 out of the 30 people think that daylight savings time should be abolished and we should just go to summertime. And the other 5 people just don't know because they didn't vote, all right? But 25 out of 30, that's a proportion. With proportions, you usually actually have less numbers to deal with, which I kind of like. And the numbers that we're dealing with are x and n, mostly. X and n is your success over your trials, or your sample size. And in stats, we generally either take that to a percent or more likely a decimal. So the fraction becomes a decimal. But we're going to be dealing with comparing proportions. So if we're comparing proportions, that means that we have 2. So we have some new symbols, which aren't really new. And we've got proportion. Population proportion. We've got sample size. And we have sample proportion. So if we're dealing with 2 proportions, then we have proportion 1 and 2. Fair warning, I can't seem to write today. I put like stray marks in different places and stuff just doesn't look right. It's just one of those Wednesdays. So proportion 1, proportion 2. So how do we designate a difference? We use some either number or letter. In this, as the example, we use numbers, but in the real problems we may use letters. Maybe we're comparing men to women like we're going to do in a problem here in a little bit. So instead of using a 1 and 2, we might do PM for proportion of men and PW for proportion of women. However you want to do that, whatever makes sense for the problem is fine. N1 and N2 are 2 different samples. And then the sample proportion is going to be P hat 1 and P hat 2. So I probably ought to say that the second semester is all about conditions, really, because that's the big part of this. The calculation's fairly simple. especially if you cheat and use the calculator, which I totally support. Okay. The conditions are what they've always been for proportions. Is it an SRS? But now both samples have to be an SRS. So both samples can be viewed as SRS from their respective population. Both samples. Are randomly chosen. I'm going to change it a little bit. From their respective population. The next thing is it independent? That's the 10% rule. Independent is going to be, so 10% of your first population has to be greater than your sample size for the first population. And since we have two populations, we've got to check it for both. So 10% of the second population has to be larger than your second sample size. And again, both have to be true, otherwise we just shut her down. Or maybe we just say, hey, this isn't true, but I'm going to go on anyway. So that's probably how I would handle it. And the last thing? But CLT doesn't work for proportions. NP greater, yeah. So is it normal? Norm. So you'd have to go N1 times P1, right? Because you have two different proportions and two different samples. Has to be greater than 10. And then N1 times 1 minus P1 has to be greater than or equal to 10. Wait a minute, greater than. No, greater than or equal to. Sorry. Getting things mixed up in my head. And then also for the second proportion, N2 times P2 greater than or equal to 10. And N2 times 1 minus P2 greater than or equal to 10. So all four conditions have to be met there for this, the normal. Yeah?
Do these things ever mix? So like N1 and like P2?
No.
No.
No. You keep them together with the proportion and the sample size have to go with the same group. Yeah, they wouldn't mix. So when I was reading through this in the book, I was remembering something different from last year and the previous 2 years. So I went back to my old book, which is about 10 years old now. Again, written by the same guy basically, but it's not quite as good as this one. But in that, it used the tens, but it also said that if you have at least 5 in each of these, you're okay. But the new book doesn't say that, so I don't know if there's been a change. So here's what I'm going to say for those of you who are, thank you. For those of you who are going to take the AP test, if you test this out, my guess is any of the AP test questions are going to give you a 10, at least 10 in all these. But if you get one that's less than 10, but at least 5, go with it. Go with it. Okay. So the previous book said 5 is okay. And that's kind of what I'd remembered. But this book, not so much. Anyhow, it may not be an issue at all. I'm mentioning it. I'm not writing it. Okay, so some calculation stuff. One of the things that you will be perhaps looking at is P hat C. That's a p double hat. No, just a p hat. Okay. P hat C. And what this is it's the combined sample proportion. And what this is it's the count of successes in both samples over the count of trials in both samples. Which is simply just x1 plus x2 over n1 plus n2. You're just combining your total successes over total trials. It's p hat c. There's only one formula where that comes into play, but you might see it. Everybody with me? Yeah? All right. So, go to the next page, which is not that page. There we go. So, confidence intervals. That's what we're going to be looking at today. So, a two-prop confidence interval. The formula is p hat 1 minus p hat 2. Anybody, okay, this is just the part of it, but anybody have any thoughts as to why we would subtract those? Yeah. Exactly. We want to know, is there a difference between those two? All right, and it's been a while since we've done a confidence interval, but that's going to be plus or minus z star times the square root of p sub 1 times 1 minus p sub 1 all over n sub 1 plus p sub 2 times 1 minus p sub 2 all over n sub 2. You may never use that formula, okay? But we do need to know a couple of things. If p sub 1 and p sub 2 are not known, because they're population proportion values, they pretty much have to be given. Substitute. What would we substitute instead of P1 and P2? P hat 1 and P hat 2. That's right. In fact, the calculator doesn't even ask for P1 and P2. It just asks for the x and the n for each proportion. So it's not concerned at all about what the population proportion is. So if that's the case, then you're using, if you do that substitution, you're using the standard error of p hat 1 minus p hat 2, which is, if this is the standard deviation, this it's going to be exactly the same thing except with hats. P hat 1 times 1 minus P hat 1 over n sub 1 plus P hat 2 and I'm not really sure if you care about some of the rest that I'm going to have you write down here, but there's another way to calculate this. I don't know that it's necessarily easier. It could be. Probably is. P hat C, which was the formula we wrote on the last page, times 1 minus P hat C times 1 over N1 plus 1 over N2. So again, I think it's unlikely that you'll use most of that. However, if you're asked a margin of error question, what's the margin of error here? Wouldn't that be all of this? The margin of error, the z star times that? Yeah? Margin of error. So you may be asked a margin of error question. I don't know for sure. I haven't gone through all the problems in this book, but it could certainly happen. All right. So what's the shortcut? For all this, the 2 prop z int. It's the interval. 2 prop z int. That's in the calculator under your tests. And there's 2 other things before we do a problem that I want you to be aware of that may come in and help you a little bit. The difference, the mean difference, P hat 1 minus P hat 2 equals the mu of P hat 1 minus the mu of P hat 2 which also equals just P1 minus P2. So the population proportions the same as the difference in the population proportions is the same as the difference in the mean of the sample proportions. And the other one, which we kind of already know, sigma P hat 1 minus P hat 2 is this thing up here. P1, 1 minus P1 over N1 plus P2 Daylight savings time is taking its toll. Alright. Okay. So are you all with me again? Let's see. Get organized here. Let's look at a problem. That's weird. So on page 640, number 9, you can turn there if you want, follow along with me. It's talking about young adults living at home. you're 18, that's it, you're out. I don't think they believe me. I'm not sure I believe me. And I'm pretty sure that somebody at some point, because my daughter does come here in the mornings for a little bit, some of you may know her if you're in the orchestra. It's like, imagine one of these days somebody's going to go to my daughter and go, you know, your dad hates you. She's probably going to go, yeah, I know. I don't really hate her. I just don't want them to get too comfortable, right? Because I don't want them to be 40 and living in my downstairs bedroom, right? And me still cleaning the toilets for them. Okay, that's just not going to fly. So young adults living at home, it's definitely a thing. And what we're going to do is in this problem, we're going to compare men versus women. I have had to move home with my parents a time or two. Like when I got out of college, I moved home with my parents for a little bit before I was able to get into my own house. And I was lucky. I didn't think I was lucky in the beginning, but my parents did something when I was working as a teenager. My mom would be like, give me half. Whatever it was, give me half. And I'd have to give her half of everything I made. It's like, Mom, I need that $100. No, you only need 50. Give me half, right? So what they did with that money was they put it into my college savings. And when I went off to college, I had a pretty reasonable amount of money. There was no, unfortunately, there was a time where being a white male, my parents made like about 2 cents more than the absolute bare minimum that you'd have to make to not get any kind of support at all. You know, so I didn't have any kind of financial aid or anything like that. So I went off to school with this chunk of money. It was about $10,000, and I was pretty good about it. I actually didn't even begin to start messing with it until I was in my 20s, and like my monitor burned out on my computer, and it's like, I got to dip into that money. Well, back then a monitor was like $700. You know, it wasn't like today where you can go to the second-hand store and find one that'll work just fine for 10. Right? It just didn't happen. So then when I moved back with my parents, I had to pay rent. So I don't think I lived with them much more than about a year. But I was paying $200 a month in rent, which isn't a lot, even then, I didn't think. So I'm paying this rent, I'm kind of being fed too, and but they were taking that money and they were putting it in an account. I didn't know this. So that when I went to buy my first house, they said, oh yeah, here's some extra money that you gave us for rent to help you with your down payment. I thought that was pretty cool. So, pretty okay set of parents, but I wasn't really all that happy when I was a teenager giving half of my $100 away. So, all right. So in this problem, it says that a surprising number of young adults, ages 19 to 25, still live at their parents' homes. The National Institute of Health surveyed an independent random sample of 2253 men and 2629 women in this age group. So I'm going to write something down here. I've got the number of men, it was 2253, and the number of women, instead of using 1 and 2, I'm going to use some variables, is 2629. Okay. And then it goes on to say that the survey found that 986 of the men and 923 of the women lived with their parents. So X of men is 986, X of women, 923. I'm going to have to do conditions, but to do that I'm going to need the p-values, but I don't really have p-values. I don't have the population proportions. So when I say p-value, I'm actually using that improperly, but I need p-hat. So p hat men is going to be 986 out of 2253, which is about 44%. And p hat women, 923 out of 2629. It's about 35%. So I'll need those for my normal calculations. Let's look at our conditions. Is it an SRS? Yeah, it said independent random sample for both. I'm actually going to put that in quotes. So yes, that's checked off. Does our 10% rule apply? Do you think 10% of all young men in this case 19 to 25 is greater than 2253? Yeah, I think we're probably pretty good there. And how about 10% of all young women? Greater than 26, 29? I think if I was doing this for I would definitely say this is reasonable to assume that this is acceptable. So for our purposes for this class, RTA is a thing. We'll call it RTA, reasonable to assume. But please don't use RTA on the AP test. Okay? Spell that out. Okay? It's reasonable to assume that the population of young men and women are greater than the sample size by more than 10 times. Okay. Now, is it normal? So that's going to be N, or NM, in this case, 2253 times 44%. Is that greater than or equal to 10? You bet it is. And is 2253 times 1 minus 0.44 also greater than or equal to 10? I don't think I need to calculate that. Yes. Do the same thing for the women. Oops, not 44, 35. Is 2629 greater than 0.35? Absolutely. Greater than 10. And 2629 times 1 minus 0.35. Also greater than or equal to 10. No doubt about that. So, our conditions are met. Okay. The conditions oftentimes take the most amount of time. They're, I won't lie, I think they're a pain in the butt, but we have to do it. Okay? We have to do it. All right. So, we are going to use the 2-prop zint. So if we go to tests, so stat tests, should be your new best friend. Okay? I'm looking for the 2 proportion z interval, not a test. There is a 2-prop z test as well. We want the 2-prop z int, which is down here a ways at b. 2-prop z int. And since I've already put this in, it's already got the numbers in there. X1 is going to be the number of men who live at home, and N1 will be the number of men that were surveyed. X2, the number of women that live at home and the number of women that were surveyed. So there's our two proportions. Confidence level, this question asks for a 99% confidence interval. And so I'm going to write that stuff down. X1, 986. N1, 2253. X2, 923. Confidence level 0.99, and then we'll calculate that guy. So I'm writing everything that I put in, and I'll write everything that I get out that hasn't already been written. So the N1 and the N2, I'm not going to rewrite those. I don't see a point in that. So what we get is 0.0505 to 0.12261. P hat 1, 0.043, oops, not 0.0. How about just 0.437? Actually 0.438. And P hat 2, 0.351. And I think we have everything we need, because what we really want is this right here. This is what we need right there. So again, the biggest part of the trouble, or the biggest part of the problem, is writing it down. Hey, if you can't sleep, I can't sleep. If I can't sleep, you can't sleep. That's what I mean. See, I can't even put my words together today. It's just one of those days. It's a Wednesday. All right, so how do we answer this? We are 99% confident the true difference in proportions P1 minus P2, I'll just kind of add that in there for some reinforcement, but I don't know that it's totally necessary, of young men and young women is between 0.05 and 0.12. Which proportion is larger? Isn't it the men? More of the men? Yeah, more of the men stay at home. So basically what this is saying is that, or another way to phrase this perhaps would be that between 5 and 12% more men live at home. The true difference in the means is that 5 to 12% more men live at home than women. Okay, well that was A. B is a little bit shorter. So B asks us, well, let me back up a second before I ask what B is. What would the null hypothesis be for this? If you're looking at these two, before you look at the two proportions, before you take the samples, what would the null hypothesis be about the proportion of men and women that live at home? Any thoughts on that? No. What's that? Did I hear none? think in this case, if I were writing the null and alternative hypothesis, I would say that the null hypothesis would be that the proportion of men equals the proportion of women. And then the alternative is going to be that something's different, right? If you didn't already know what the data said, what might your alternative be on this? Or they could just be not equal. I mean, if you didn't know anything at all, you might just say it's not equal. You could, but it could be an inequality too. So this is going to be greater than, less than, or not equal to. I think I would tend to lean towards this in the beginning, just because, I don't know, is it different? I don't know. Am I slanting, am I giving a bias right off the get-go by saying that more men live at home? I may be, right? So it does not equal, I think, kind of eliminates that man slam. You're one of us. Come on, man, you're slamming the man? Jeez. Give us at least the benefit of the doubt and go two-tailed, man.
After 18, you're kicking your kids out. I'm 18 and I still live at home.
Well, if you were my kid. All right. So,
We just love our parents more than the girls do. We just like them more.
is that right? You think so? So the parents are maybe harder on the girls than the guys? Maybe. Okay, so what we just found was a 99% of the time, or 99, or not percent of the time, but 99% confidence interval, we think that the true mean difference is between 5% and 12%. What does the null hypothesis indicate? There is no difference, 0%. So where would the 0 fall on our curve? It's way in the tail, right? So this no difference would be a 0, and it's way over here in the tail. So is there a significant difference between men and women who live at home? Yes, there is. So they kind of throw a little bit of a test in here based on the confidence interval. So, all right. Cool. Well, enough of me talking because I can't really speak that well today and write, so.